Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning to our lecturer, Dr. Haiza, for subject MTS 3273, Teaching and Assessment for Measurement, Geometry, Statistics and Probability. Today, me, Irshad Alfian bin Jamis, with my two other friends, which is Maria Tan Chia Ying and Nur Aisyah Akilah, will present our task 1 and task 2, group performance and group presentation about issues and challenges for topic geometry and measurement. This is our group members, me Irshad Alfian bin Jaimis and my two other friends, which is Maria Tan Chia Ying and Nur Aisyah Akilah. First, we look at our introduction part. As we know, teaching and assessment in mathematics in primary schools is important to help students understand basic ideas. However, there are problems when teaching topics like measurement, geometry, statistics, and probability. This problem make it hard for students to understand the topics well. The issues may be caused by the way lessons are taught, the material used, or how students take part in class. To learn more, we have studied 9 articles that talk about the problems, reasons, and effects of of this challenge in the teachings and learning mathematics. For our third article, or my last article, is about a comparative study of quadrilaterals topic content in mathematics textbooks between Malaysia and South Korea. The main issue and challenges in this article is about limited high-level thinking question. In Malaysian textbooks, most of the question only ask students to understand or apply what they have learned. For example, they may ask students to find a missing angle or name a shape from a picture. But in South Korea textbooks, the questions are more challenging. They ask students to analyze, evaluate, or even create something new. For example, students may need to explain why a shape belongs to a group, find mistake in the shape's description, or build new relationship between shapes. The main cause to this issue and challenges from this article is because the lack of reasoning as an instructional priority. In South Korea, textbooks include proof and logical thinking tasks starting from middle school. These activities help students think like a real mathematician by asking them to explain, prove, and understanding ideas deeply. In Malaysia, textbooks rarely include this kind of reasoning task. This may be because some teachers or textbook writers think students are not ready or that there is not enough time to cover everything in the school syllabus. As a result, students do not get enough practice in critical thinking and reasoning. The effect from this issue and challenges is the consistent underperformance in international assessment. International test results like TIMSS, Trends in International Mathematics and Science Study shows that Malaysian students perform worse in geometry compared to students in South Korea. For example, in 2015, TIMSS 87% of Korean students answer a sample geometric question correctly, but only 32% of Malaysian students got it right. So, the fourth article will be presented by Maria. Next, we look at our second article, which is the analysis of misconception on learning geometry for second grade primary school pupils by Nazari et al. 2022. For this article, the main issue and challenges is about limited retention without guidance. Most students cannot remember or explain geometry topics on their own. They need help from their teachers or friends to understand the lessons. This shows that they have not truly understood or remembered knowledge deeply. Instead of learning to think on their own, they rely too much on others. For example, more than 80% of the students in the study needed the teacher's help to remember the parts and features of 3D shapes. The main cause to this issue and challenges is student lack of effective teaching aids. Teachers said that their classroom do not have enough teaching tools like shape model, picture, or hands-on materials. Many students could not understand or name a shape unless they could see or touch it. Because lessons are rely too much on textbooks and spoken explanation, students do not get the chance to develop strong shapes and space understanding. And the effect from this issue and challenges is student limited progression in STEM. Geometry is very important for subjects like engineering, architecture, computer science, and robotics. If students have trouble with seeing and understanding shapes in their mind from a young age, they might feel like the subjects are too hard for them. This may lead them to avoid STEM subject in the future, which can limit their career choices and opportunity. Now we look at our first article, which is the effectiveness of teaching aids based on the achievement and interest of students in the field of measurement and geometry by Shaimi et al. 2023. The main issue and challenges in this article is student lack of visual spatial skills. Geometry and measurement requires students to be able to see shapes in their mind, imagine how the shape move or rotate, and understand how different shapes fit together. However, many students not been given enough practice or training to build these skills. As a result, they find it hard to understand even simple geometry topics. The main cause to this issue and challenges is students overemphasize on memory instead of conceptual understanding. Some teaching methods focus too much on memorizing the names and features of shapes instead of helping students understanding how the shapes work or connect together. When students only memorize facts without really understanding them, they often learn things the wrong way. These mistakes stay with them and are hard to fix later. The effect from this issue is it's widening the knowledge gap between the student and other students. Students who are not good at visualizing shapes often fall behind their classmates. This create a bigger and bigger gap between them and the others. The student may feel discouraged and lose confidence in learning math. Because of this, they might choose not to study subjects like science or engineering in the future. When there is no proper help given to them, this problem can continue for a long time and learning unequal for everyone.
Hello, I am Maria and I'm going to share about Article 4, Article 5, and Article 6. So, what is the Article 4? It is the analysis of weaknesses among second grade primary school pupils on learning geometry topic, which is written by Muhammad Basri Nazri, Muzira Musa, Chu Chengmeng, and Irwan Mahazir Ismail, published in 2022. So, what is the issue and challenge highlighted in the article? It is the weakness in understanding and applying geometric concepts, especially 3D shapes. Many second grade pupils face significant challenges in recognizing, drawing, and understanding the properties of three-dimensional shapes such as cubes, cuboids, and pyramids. This difficulty stems from limited visual spatial skills and insufficient exposure to hands-on or visual learning materials that support conceptual understanding. So what is the cause of it? It is because many students have low visual and spatial skills. Many pupils in the study couldn't visualize or mentally manipulate 3D shapes, which is crucial for understanding geometry. For example, when asked to draw or identify 3D shapes like cubes or cuboids without concrete objects or teacher guidance, people struggle or froze. This shows that they lack internal mental imaginary skills essential for tasks like imagining how a net folds into a shape. So, what is the impact? This will cause difficulty in understanding and drawing nets of 3D shapes. As a result of their weak visual skills, students could not recognize how flat 2D nets translate into 3D objects. For instance, many mistook a CubeNet for a different shape or couldn't visualize the final shape at all. This gap prevents them from mastering even the basic requirements of the curriculum and makes it harder for them to progress in geometry. Next, I will talk about Article 5, which is Conceptual Knowledge in Area Measurement for Primary School Students, a systematic review, written by Hafiz, Suzelis, and Hood-Kemry, published in 2022. So, the issue and challenge highlighted in the article is students struggle to master geometry reasoning and problem-solving skills. Studies reveals that many Malaysian primary school pupils struggle with geometry reasoning. Their difficulties include identifying, analyzing, and applying geometrical concepts, especially when dealing with non-routine tasks that require logical thinking and problem solving. This impacts their ability to approach geometry beyond memorization. So, what is the cause of it? It is because of the overemphasis on rote learning and lack of exposure to higher order thinking tasks. The current teaching practices in primary schools tend to focus on drill based and procedural learning rather than conceptual understanding. Pupils are not often exposed to tasks that stimulate reasoning, logic, or problem solving. As a result, they are not trained to think critically or apply geometry in unfamiliar situations, and this will affect their poor performance in non-routine geometry tasks and inability to apply concepts meaningfully. Due to limited exposure and lack of proper scaffolding, pupils find it challenging to solve geometry problems that require special visualization, strategic reasoning, or multi-step solutions. They often rely on trial and error methods or guessing rather than logical thinking, which hinders their performance in complex geometry questions. So, the last article that I am going to share is about teaching and learning of probability, written by Carmen and Roggio, published in 2023. So, the issue and challenge highlighted in this article is about the misconceptions and reasoning biases in probability concepts. Learners exhibit persistent misconceptions in probabilistic reasoning. These include misinterpreting randomness, misunderstanding independence, struggling with conditional probability, and showing biases, such as representativeness and best rate fallacy. These misconceptions persist even after formal instruction. So, what is the cause of it? It is because of the lack of deep conceptual and epistemological understanding of probability. Probability is taught mainly through classical or frequentist perspectives, often without linking it to real life context or incorporating subjective, axiomatic, or modeling approaches. Furthermore, teaching materials and exams focus heavily on procedural tasks without addressing intuitive and informal reasoning. Many teachers themselves also lack sufficient mathematical and didactic knowledge to teach probability effectively. As a result, this will this will give them the low performance in probabilistic problem solving and limited decision making ability in real life contexts. Students will struggle with applying probability concepts meaningfully, especially in complex or real life situations like Bayesian reasoning or risk analysis. This will lead to poor mathematical literacy in uncertainty contexts, weak foundation for inferential statistics, and even challenging in interpreting probabilistic information used in daily life and professional decisions. So that is all that I am going to share. So I will pass the next presentation to Aisha.
So the next article is about element across the curriculum in primary school mathematics textbooks, a Malaysian perspective by Muhammad R. and Ghazali M. So first of all, the issue that's stated in this article is the statistic and probability like real life context in exercises. In our country, Malaysia, the primary maths curriculum core topics like measurement and geometry are often presented in isolation without connection to real life situation or cross curricular themes. Similarly, statistic and probability are usually taught through repetitive exercises, making deeper conceptual links or practical applications. So the causes that being stated in this article is also true, which is first of all the curriculum or emphasis on physical knowledge of conceptual understanding and textbook like sufficient cross-disciplinary examples and hands-on tasks. This challenge stems from our emphasis on procedural skills such as formula memorization and rule based on problem solving within the textbook and teaching approaches. The limited use of interdisciplinary example or contextualized learning thus result in a lack of relevance to students' daily experiences. Furthermore, the teaching aids and resources that could bring abstract concepts to life are also underutilized. So the effects are, as a result, the students are struggling to relate the mathematical knowledge to practical scenarios, which hinders their problem solving. So we can see that the students are struggling to apply all the concepts in daily life, especially about the probability and also the measurement and geometry. So the next article is about explainable AI and deep learning models for recommender systems by Fu, Liu, and Zheng 2023. In this article, the issue and challenges stated is about the students that have different learning styles and paces, especially in abstract topics like probability and statistics. So in our country, Malaysia, the primary students exhibit a wide range of learning styles and abilities, particularly in complex topics like probability and statistics. However, the most classroom instruction remains uniform, lacking the differentiation to address students' unique learning needs, pace, and prior knowledge. So, this caused two things. The first of all about the lack and personalized learning tools in current teaching methods, and secondly about the minimal use of adaptive digital content in classroom settings. This issue arises from the limited access to AI-powered personalized learning tools in local schools. The integration of technology in mathematics education is still minimum, and the most digital tools used in class are not adaptive or tailored to students' individual performance data. The teachers also lack sufficient training on how to implement differentiation interaction using data analytics of deep learning systems. Then, this affects the students with different abilities get left behind. The students who need more support often fail because the learning materials and pace are not suit their level. This also causes to lower their confidence and also reduce the precipitation in topics like statistics and probability, where the conceptual understanding is essential. Then the teachers may also feel overwhelmed having to manually differentiate instruction without the act or also the aid of intelligent system, potentially resulting in teaching fatigue and inefficiency. The last article is about a review of explainable graph-based recommender system by Marcom S. et al. 2024. So, first, the issues and challenges that stated in this article is the difficulties in tracking student learning patterns across math topics like measurement and statistics. Teachers in Malaysia primary school often find it challenging to monitor and track student understanding across the iterated math topics such as measurable, statistic, and geometry. The misconception of learning gaps frequently go unnoticed until end of term assessment, making the early intervention difficult. So the cause of this issue is the lack of data-driven tracking system in primary school setting. The primary cause the lack of data-driven system or analytic tools that can track students' learning behavior in real time. The traditional method based on rigid digital assessment failed to capture nuanced patterns of student progress. There is no an absence in of visual and explainable analytics for teachers to easily interpret learning strategies and spot weak areas. So the effects are three. First is the gap of the knowledge go unnoticed until the formal exam. Second, the slower students are not given timely support or intervention. And third, the teacher rely heavily on summative assessment rather than the continuous formative data. So, consequently, students may continue to accumulate learning gaps over time, which becomes more problematic in cumulative topics like probability and statistics. Without the real time feedback loops, teachers are less equipped to provide timely, personalized support. This reactive approach reduces the overall effectiveness of the teaching and learning process and contributes to widening the performance gaps within the classroom itself. So now we go to the summarization. There are nine issues and challenges for these all nine articles, and there are 12 causes, and also there are 10 effects that have been presented by all the three presenters. Now, the next slide is about the references, and that's all our presentation for our group. Thank you.